Let's start the first chapter of chemistry, which is chemical reactions and equations. In this chapter, we are going to understand some of the very important topics of chemistry. So, the first topic that we are going to cover is what is chemical reaction. And then we will see how to write a chemical equation. So, these two topics we will cover first. And then the next topic is how to balance a given chemical equation. So the next topic is balancing of chemical equation. The third topic that we will understand is a very important topic of this chapter, and this is different types of chemical reaction. We will see what are different types of chemical reaction. At the end, our fourth topic is a very special type of chemical reaction, which is redox reaction. And we will finish this chapter by looking at some of the application of redox reaction in our daily life. Okay, so let's get started with our first topic, which is chemical reaction. So what is chemical reaction? Before understanding this concept, we all should know that every matter undergoes two types of change. We already know this from our previous classes that every matter undergoes two types of change. First type is physical change, and the second type of change that matter undergoes is chemical change. We all know this thing. So let us see one example here. What happens when ice block or ice cube is kept at room temperature? What will happen to it? Ice cube, if it is left open at room temperature, what will happen? It will melt and form liquid water, isn't it? Will melt and form liquid water. Now, what is happening over here is ice cube, which is basically water, made up of water only, H2O. Chemically it is H2O, and liquid water is also H2O only. So here we can see that identity or the nature of initial substance is retained, right? So the identity of substance or the initial substance is retained in this type of change, and hence such type of change or this type of change is called physical change. Physical change. Similarly, what happens when we melt a solid wax? What will happen to it? It will convert into liquid state, but again it will be a wax. So again, the melting of wax is also a type of physical change. Now consider a situation. What will happen if milk is left at room temperature during summers? What will happen to that milk? If it is left for too long time, it will lose its identity and convert into curd. This curd may not be edible, so it will become curdy, you can say. The milk will become curdy. So milk here loses its identity as well as it loses its nature. So this curdy substance does not taste like milk, does not smell like milk, its texture is different, and also smell is different, and in fact chemical composition is also different. So what is happening over here is basically the sugar present in milk gets converted into lactic acid in this curdy substance. So this type of change where this initial substance loses its identity or loses its nature is called chemical change. So this is chemical change. So now we know that there are two types of change that any matter can undergo. One is physical change, where initial substance do not lose its nature as well as its identity. And the second type of change is chemical change, where the initial substance loses its nature and identity completely and forms a new product. Now we say that whenever chemical change is taking place, we call it as a chemical reaction. We say that chemical reaction has occurred here. So whenever there is a chemical change, we say that chemical reaction has occurred. So now you must be wondering, what is chemical reaction then? So chemical reaction is a process. Basically, it is a process in which one substance loses its identity and forms a completely new substance. Or you can also define it like this, that it is a process, chemical reaction is a process in which initial substance gets transformed into a new substance. So you may note this down also in your notebook if you want, this definition of chemical reaction. You just pause it, rewind it, and note it down. So now we are fully aware of this concept, what is chemical reaction. Now let us see some more examples from day-to-day life, and also we are going to see some more examples of chemical reaction that we can do in laboratory. Okay, so let us now see some of the examples of chemical reactions from daily life. So one example you have already seen, which is formation of curd. Formation of curd from milk. So what happens here is the sugar, which is lactose, this is milk sugar, gets transformed into a new type of substance, which is lactic acid. Lactic acid. This is found in curd. And this process is facilitated by a bacteria. The name of bacteria is Lactobacillus lacti. Name is not that much important, but we should understand that it is a process of chemical reaction where lactose of milk gets converted into lactic acid. So one substance or the initial substance loses its identity completely and forms a new product. Second example can be rusting of iron. Rusting of iron. What happens here is iron in humid atmosphere, when iron is kept in humid atmosphere, it forms rust. Now rust is basically oxide of iron. It gets converted into oxide of iron. This is called rust. It is brown in color, very brittle, and iron, which is very shiny and very strong. Now we can see that the initial substance, which was iron, is completely transformed into a new substance, which is oxide of iron or rust, and hence again it is an example of chemical reaction. Another very common example is fermentation of grapes. Fermentation of grapes. Now, it is the process through which wine is produced. What happens over here is the sugar present in grape gets converted into alcohol. Now you can see that initial substance is changing itself into a completely new substance. Again, a chemical change and chemical reaction is taking place in this process. Now this process needs assistance of yeast. The process is carried in presence of yeast. Another example from daily life is the process of respiration. What happens in this process is glucose in presence of oxygen gets converted into carbon dioxide, water, and also it releases energy which is required by our body for its proper function. Now we can see that initial substance is getting transformed into completely new substances, and hence it is again a chemical reaction. Now there are several other processes also. For example, photosynthesis is also a type of chemical reaction. Cooking of food is also chemical reaction. What happens in cooking of food is the cooked food is very soft, its texture is different, its taste is different, and hence there must have been some changes in its structure, in its chemical nature, and hence it is a chemical reaction. The process of digestion is also a chemical reaction. Lots of chemical reaction takes place during the process of digestion, so we can say that it is also an example of chemical reaction. So now these are a few examples that we may or may not encounter in our daily life, but it is happening around us. Okay, so now we're going to see some examples of chemical reaction that we can or we may perform in lab. So the first example is burning of magnesium ribbon. As you can see here in this animation, magnesium ribbon is burning with a very bright light. It produces a very bright light when it catches fire, right? So what is happening over here is when magnesium metal burns in air, it is combining with oxygen present in air and it forms magnesium oxide. So what happens in this reaction is this magnesium ribbon, which you can see, this ribbon which is carried using a tongue, when it is kept over a flame, it catches fire in some time and it produces a very bright light. See, and this is the reason why magnesium metal is used in firecrackers. And this is what is happening chemically in this reaction. The next example of chemical reaction that we can perform in lab is the reaction of lead nitrate with potassium iodide. Potassium iodide is Ki, its formula, and lead nitrate is Pb3 twice. What happens in this reaction is when potassium iodide is added to lead nitrate solution, both are water-like solution as you can see in this image. So let us say this one is lead nitrate and the component in this solution in this beaker is potassium iodide. What happens when potassium iodide is added to lead nitrate? You see very carefully, a yellow colored substance is forming in this reaction. What is happening over here is lead nitrate when combines with potassium iodide, new substances are getting formed here. So one is this yellow colored substance is lead iodide, and the other substance which gets formed, which is a colorless substance, is potassium nitrate. Sorry. So we have two new substances here from two initial substances. Now this is yellow in color. This is yellow precipitate. In short, it is written PPT, which is insoluble in this liquid. Now, in this reaction, we can see that color of substance is changing from transparent to yellow. In the previous reaction, what we saw is, in this reaction, what we saw is the texture of the substance was changing. So magnesium is a solid metal, and when it burns, it produces a white color powdery substance, which is magnesium oxide. So this is white powder. Now the third example of chemical reaction that we can perform in lab is reaction of a zinc metal with HCl, hydrochloric acid, or sulfuric acid, H2SO4. So this one is hydrochloric acid, and this one is sulfuric acid. So when zinc, which is Zn, combines with HCl or H2SO4, it forms a salt, which is zinc chloride, and it liberates a gas, which is hydrogen in this case. Again, when zinc reacts with H2SO4, sulfuric acid, the reaction will be very similar. It will form a salt, which is zinc sulfate, and will produce hydrogen gas again. So in both of this reaction, what we can see is hydrogen gas is escaping out from the liquid. So let us see this reaction, how it happens. So in this test tube, we have hydrochloric acid, which is transparent in color, and we added a piece of zinc metal, and now you can see these bubbles are forming in this solution, and these bubbles are nothing but hydrogen gas, which is trying to escape from this liquid. Okay, and once the reaction is complete, so the reaction mixture will be zinc sulfate and hydrogen will be liberated. So these are a few examples of chemical reactions that we can perform in a lab. Okay, now we are going to see what helps us to determine whether chemical reaction has taken place. Now there are several parameters with which we can say that chemical reaction has taken place or not. So first, such a parameter would be change in state. Change in state. So if there is a change in state of the initial substance, then we can say that a chemical reaction may have taken place. For example, burning of wax. Burning of wax. We must remember this concept that all of these burning reaction or combustion reaction takes place in air. That means Oxygen is required. So the substance combines with oxygen to form product. Mostly these products are oxide. So in this case, wax, it is solid or maybe liquid, burns in oxygen and forms carbon dioxide, some amount of water, heat, etc. So these are the major products, carbon dioxide and water, which is formed in this reaction. So from solid to carbon dioxide is gas. So there is a change of state, or we may also say that if wax is liquid, then from liquid to gas. So there is change in state taking place in this reaction. So whenever there is change in state, then we may say that chemical reaction has taken place. The second parameter is change in color. We have already seen this in previous examples where lead nitrate combines with potassium iodide to form lead iodide, and we have already seen this, that lead iodide is yellow in color, whereas the initial substances lead nitrate and potassium iodide, they were transparent. So whenever there is change in color, so you can quote same example here, lead nitrate plus potassium iodide, it forms lead iodide plus potassium nitrate. Now this is transparent, this is also transparent, this is yellow in color, this is again transparent liquid. So there is change in color in this case, and the change in color indicates that some chemical reaction has taken place. Third parameter is evolution of gas. Again, we have seen this example where when zinc is added to either HCl or H2SO4, hydrogen gas evolves in that reaction. So we can again quote that example here also. So zinc, when reacts with HCl, it forms zinc chloride along with hydrogen gas, which evolves out of mixture. So you must be seeing that I am using this upward arrow sign in front of gases because they evolves out of the mixture. So for gases, for gaseous products, we use upward sign, upward arrow sign. Now, in these chemical reactions, we know that these are the initial substances and these are the final substances. Initial substance is transformed into new substance. So these initial substance or initial substances, they are called reactants. So in chemical reaction, initial substances are written left of this arrow sign, and the final substances is called product, which are written right to the arrow sign. Now there are several other parameters also which we can use to determine whether chemical reaction has taken place. So the next parameter is change in temperature. Change in temperature. If during reaction the temperature of reaction mixture increases or decreases, then we can say that something is happening inside that reaction mixture. That means there is some chemical reaction taking place inside it. So for example, the above example where zinc reacts with HCl, it forms zinc chloride as well as hydrogen gas along with evolution of heat. So heat also evolves in this reaction. It generates a lot of heat. So you can feel this heat. If you touch that boiling tube or test tube, you will feel that heat. It becomes very hot. The surface of that test tube becomes very hot. So this is again a parameter to determine whether chemical reaction has taken place or not. So you can again quote the same example here. One more parameter can be, we can say, let's say, evolution or production of light. It's better to write evolution of light or even sound. So that burning of magnesium ribbon, it produces very bright light, or firecrackers also produces a very bright light. So that means some chemical reaction is taking place here. So if there is some evolution of light somewhere, if something is burning, definitely chemical reaction is taking place. If any sound comes out from reaction or from a substance, it also means some chemical reaction is taking place in that substance. For example, explosions, those explosives, they explode because of chemical reaction that takes place inside those explosives. So you can quote example of magnesium, burning of magnesium here, or explosion of firecrackers. So those examples you can quote over here. And so these are different parameters with which we can determine whether chemical reaction has taken place or not. So now let us see what is chemical equation. Let us take one example, which is burning of magnesium. Burning of magnesium. What happens here is magnesium, or let us say, let me write full name. Magnesium combines with oxygen gas to form or to produce magnesium oxide. This is the chemical reaction which takes place during burning of magnesium. So the same chemical reaction, which is burning of magnesium, can be represented using this equation, right? This is an equation which represents a chemical reaction which takes place during burning of magnesium. And this type of representation of reaction is called chemical equation. This is nothing but chemical equation, right? What is chemical equation? It is nothing but representation of chemical reaction. So chemical equations are used to represent a chemical reaction. Used to represent chemical reactions. Now, there are two ways in which this reaction can be represented. One way is written like this, where we have used the complete name of reactants and products. The other way to write same equation is by using atomic symbols and formulae of the substance. So another way in which this reaction can be written is like, so for example, symbol of magnesium is Mg, oxygen gas is O2, and when they combine, they form magnesium oxide, which is MgO, right? So this is another way to write same equation using symbols and formulae. This type of chemical equation is known as word equation. This is known as word equation, and this type of chemical equation is known as, normally it is known as chemical equation using symbols and formulae. So, so when we say chemical equation, so we mean this thing. That means using symbols and formulae. So this is simply chemical equation maybe in bracket I may write using symbols, uh, symbols and formulae. Okay. So in general, chemical equations generally represented or written like this, not like this using word equation. Okay. Now, uh, one thing that I would like to highlight here is this in this chemical equation. Let me write it again. Magnesium, when reacts with oxygen, it forms magnesium oxide. Now, we are fully aware of law of conservation of mass. Law of conservation of mass. So, during chemical reaction, mass is conserved. That means total mass before reaction and total mass after reaction that must remain same, right? Let us say mass of magnesium, if it is m1, if mass of oxygen is m2, and let us say MgO, mass of MgO in this reaction is m3, then as per law of conservation of mass, uh, sum of these two masses must be equivalent or equal to mass of product. For this to happen, for masses to remain conserved, the number and types of atoms in the reactant must be equal to number and type of atoms in the product. So now let us see what is happening in this reaction. So we have one magnesium in reactant, one magnesium atom in product, two oxygen atom O2, right? So in oxygen gas we have two oxygen atoms, and here we have only one oxygen atom. So this number is not balanced, and hence mass is not conserved, but it should always be conserved, and hence there is a need to balance these numbers, or there is a need to balance mass. So the chemical reaction or chemical equation which is written in this form, where total number of atoms towards left or in reactant is not equal to total number of atoms in product, such type of reaction or equation is called unbalanced chemical equation. This is unbalanced chemical equation, and we must always balance it to make it a true chemical equation, because this law is always followed. So masses must remain conserved. So total mass of reactant must always be equivalent or equal to total mass of product. This unbalanced chemical equation is also known by another name, which is called skeletal chemical equation. Skeletal chemical equation. Now, a skeletal chemical equation is just a representation of chemical reaction. That means this chemical equation uh, provides the initial information that these two substances are reacting and this substance is formed. Magnesium and oxygen, in this reaction, magnesium and oxygen are reacting and they are combining to form magnesium oxide. Now, how many atoms of oxygen and magnesium are combining to form how many atoms of or how many molecules of magnesium oxide is not, that information is missing in this chemical equation, and hence it is unbalanced, or it is just a skeletal chemical equation, and there is a need to balance it, which we are going to see in the next lecture. We will see how to balance a given chemical equation. So now I hope that the concept of chemical reaction and chemical equation is clear. So what is chemical reaction And what is chemical equation? This concept we must uh, be very clear about these two concepts. So, chemical reaction is transformation of one substance into new substance. So, it is transformation of one substance into a new substance, right? And chemical equation. So it is basically it is a way to represent chemical reaction. So we can say that it is symbolic representation of symbolic representation of chemical reaction. Chemical reaction uh, using atomic symbols and formulae. Using atomic symbols and formulae. Okay, so now we will see how to balance chemical equation. Okay, so now let's see how to balance a chemical equation. So for this, we must have a chemical equation. So let us write our previous chemical equation, which is uh, burning of magnesium. So magnesium combines with oxygen gas to form magnesium oxide. And as per law of conservation of mass, total mass in reactant or total mass of reactants must always be equal to the total mass of product, and that can be achieved by balancing the number of atoms of each element in reactant and product side. So let us try to balance this equation first. So we see that in product we have one magnesium atom, and in reactant also we have one magnesium atom. So it looks like magnesium atom is, so the number of magnesium atom is balanced so far. When we see oxygen, so in reactant side, oxygen atom, so there are two oxygen atoms here. We see O2, two oxygen atoms, and at this side we have only one oxygen atom. So oxygen, number of oxygen atoms are not balanced in this case. And in order to balance it, what we need to do, or what we can do, is we can put 2 over here. We're going to put 2 as a coefficient of this compound. Okay, we cannot put here because that will alter the chemical composition of compound. That then this compound is no longer magnesium oxide. Formula of magnesium oxide is MgO only. And as soon as we have written 2 as a coefficient before magnesium formula of magnesium oxide, now this 2 belongs to both magnesium as well as oxygen. So now we have 2 oxygen atom in product side, 2 oxygen atom at reactant side, but it has disturbed the number of magnesium atom now, because now we have we have got 2 magnesium atom in the product and only one magnesium atom or at the reactant side. So again we must balance this also. So for that we should put 2 over here. You see, 2 magnesium atom in reactant, 2 magnesium atom in product, 2 oxygen atom reactant, 2 oxygen atom in product, right? So this 2 belongs to both. So now this is balanced chemical. We will see, I will tell you the method how to balance this. This is just an example that I am showing right now. This is balanced chemical equation. So the method which I have used here is, I mean, this is not any specific method, and hence the name of this method is simply hit and trial method. So we have balanced this using hit and trial method, right? So we will use only this method to balance other chemical equations also. We are not going to use any other specific methods. Those you will study in your next grade. At this level, we are required to balance chemical equation only using hit and trial method. So for that, I will start with another example. So let us start with a new example and try to balance. So we will balance it together. So this reaction or the equation is written like this. So when iron reacts with water, it forms Fe3O4 plus it also forms hydrogen gas. So first of all, we know that number of atoms, we must always remember this line that uh, number of atoms of each element of each element must remain same on both the side, or must be same on both the side. I mean, both the side means towards reactant and towards product side. So now we have hydrogen element. So in reactants, what we have in this equation is iron element, hydrogen element, and oxygen element. And then the product will also have same type of element. So again, we have iron, oxygen, and hydrogen elements. Now, the number of atoms in iron is only one, Fe, only one Fe. And at product side, what we can see is there are 3 atoms of iron, right? So iron is not balanced. Then what about hydrogen? There are 2 atoms of hydrogen, and at this side, the number of atoms of hydrogen is 2 only. So it looks like it is balanced. So of course, the hydrogen atoms right now, they are balanced. And oxygen, only 1 oxygen at this side and 4 oxygen atom at this side. So oxygen is also, the number of oxygens atoms are not balanced. So now we will try to balance this, and to balance this we need to follow 2 rules. This is hit and trial method, and in this method also we are going to follow these 2 simple rule which will make your life very easy. It will be easier to balance any given chemical equation using hit and trial method if you're following these 2 rules. And these 2 rules are, so the first rule, let me first put it down here. The first rule is do not change any of these numbers. Never try to change these subscripts written along with atom. They are the part of formulae, they are part of compound, and we should not change it. For example, this is H2O, which is water. And let us say if you want to balance this, there are 4 oxygen and you just randomly put 4 here just to balance oxygen atom, so it won't be water. Now H2O4 is not water, therefore we should avoid doing these mistakes. So we should not change any number within the compounds itself, within the compounds itself. That is to say, we should not change subscripts. Should not or must not change subscripts, right? Subscripts are those numbers which are written at the bottom of these alphabets. So if we are not allowed to change subscript, then what we should do is we can change coefficients. Coefficient means we can add any number before these formulae. So we can change coefficients. This we can do. We can put any number over here, or in before any formula or element, we can put any number, but we should not change the subscripts. The next rule is always start balancing the compound, containing maximum number of atoms, containing maximum number of atoms. So we must always start balancing that compound which has got maximum number of atoms. For example, if we are considering this chemical equation, so we have several compounds here, and we can see that okay, let's say water is a compound. How many atoms are there? So two hydrogen and one oxygen. That means there are total 3 atoms in this compound. What about Fe3O4? So we have 3 iron, 4 oxygen atoms. So total we have 7 atoms in this compound, and here only 2. So the compound having maximum number of atom in this case is oxide of this iron, which is Fe3O4. So we will start balancing that compound which has got maximum number of atom, irrespective of position of this compound. That compound with maximum number of atom, it can be towards reactant side and it can also be towards product side. But we will always start balancing that compound only, irrespective of its position. Right. So let us start balancing this using these two rules. So again, on the next page, we will write that equation again. Fe plus H2O, and then write the products Fe3O4 plus hydrogen gas. So before balancing, what we are going to do is we are going to draw boxes. We are going to enclose all these reactants inside box. I'll tell you the reason why we are enclosing them in box. You need not to do it once you are familiar with the process of balancing. But before that, these boxes will help you to avoid committing mistakes while balancing. So now we have these all our compounds, both reactants and products, enclosed inside box. Now we are not going to touch any number which is inside this box, right? So 3, 4, 2, 2 here, and this 2 here, 1. So if nothing is written, that means 1. So we are not going to change these numbers. So this is the first rule, and hence we have logged those numbers inside box right now. We are now going to choose that compound which has maximum number of atoms. So now we are going to use second rule, and using that rule we found that Fe3O4 has maximum number of atoms. So let us change the color of this box so that we can concentrate on this. changing. I'm hoping that this box is visible. So we have 3 atoms of iron in Fe3O4 and we need to balance it. Now let us see here. What we have got is we have got only 1 atom of iron, and in order to balance it we should have 3 atoms of iron towards reactant side also. So to make it 3, we will write 3 just before Fe. So it makes 3Fe. So now we have 3 atoms of iron. Alright, so iron is now balanced. Now the next atom in this compound is oxygen, and there are 4 atoms of oxygen in this compound and we need to balance it. And here towards this side, towards reactant side, we have only 1 atom of oxygen, and this is present as part of a water molecule. So to balance this 4 atom of oxygen in Fe3O4, we must write 4 just before H2O. Now this 4 now belongs to all the atoms which are present inside box. So the 4 belongs to this H2 also, and 4 also belongs to oxygen atom. So as soon as we have written 4 before H2O, it makes 4 atoms of oxygen and how many atoms of hydrogen? So in compound itself there are 2 hydrogen atoms. Now we are taking 4 such compounds. That means 4 H2O. Let me try to explain these things. 4 H2O means there are 4 H2O molecules. 4 H2O. See, if something is written like this, 4 H2O, it means we have 1 H2O, 2 H2O, 3 H2O, and 4 H2O. So now in the 4 molecules of H2O, what we have got is 4 atoms of oxygen and 8 atoms of hydrogen. So basically you just multiply this coefficient with the subscript and you will get the total number of hydrogen atom. So we have 8 atoms of hydrogen. Now this is balanced. So 4 oxygen, 3 iron. What about other atoms? So after balancing this, now we will see all the atoms are balanced or not. So here we have 2 hydrogen atom, and this side we already have 4 hydrogen atoms in H2O molecule. Now in order to balance hydrogen atoms, so basically we have overall we have 8 hydrogen atoms at this side, and here only 2 hydrogen atoms. And to balance this, what we should do is we should write 4 in front of H2O also. Again, you will have to think all these things because this is just a hit and trial method. So you will have to be very conscious of these things, that how we should proceed to balance each and every atom. Those rules that I have told you in the previous slide, those 2 rules are, they are not any law, they are just simple rules that you may or you may not follow. If you are following that rule, it is going to make your life bit easier. Otherwise also you can, using your intuition also, you can balance these equations, but following those rules will make, of course it will make life easy. So now this is balanced. So balanced chemical equation will look like this. So now let me write the balanced chemical equation. So we will write 3Fe plus 4 molecules of H2O, and it gives Fe3O4, so 1 molecule of Fe3O4 and 4 molecules of hydrogen gas. So this is balanced chemical equation, right? Okay, we will see a few more examples of balancing. So first example, let us take the example of a burning reaction again, which is burning of methane, let us say CH4. So this is second example. So we have methane. So this CH4 is methane. When it burns, so burning takes place in oxygen, so it combines with oxygen and it forms carbon dioxide and water. So any fossil fuel, when burns, the major product is always carbon dioxide and water. Now let us first see whether the reaction is balanced or not. So let us see each element and let us count its number. So we have one carbon atom at this side, one carbon atom this side, four hydrogen atom. Here only two hydrogen atoms, so it is not balanced. Two oxygen atom, and at this side we have two oxygen in CO2 and one in H2O. So overall three oxygen atoms in product, two oxygen atom in reactant, three oxygen atom in product. So again oxygen atom is not balanced. So we should proceed towards balancing this equation. Now the first rule is we should not in fact change these subscripts. So to avoid that thing from happening, just put boxes, and we are not going to touch any number which are inside or enclosed in these boxes. Now find that compound which has maximum number of atoms. So I think it is CH4. It has 5 atoms, 4 hydrogen and 1 carbon. And all other compounds have three maximum of 3 atoms. So CH4. So let me change the color of this compound of this box. Okay, so it is CH4. So one carbon atom towards product. So carbon atom is balanced. What about hydrogen atom? So here we have 4 hydrogen atoms, and at this side we have 2 hydrogen atoms, which is a part of water molecule. Now to make it 4, what we should do is we should write, so we already have 2 atoms, to put 2 over here as coefficient of, so take 2, basically take 2 molecules of water, right? So we have one H2O and 2 H2O. It makes 4 hydrogen atom, right? Okay. Now the moment we put 2 as a coefficient of water molecule, it makes 2 oxygen also. 2 belongs to both hydrogen as well as oxygen. So right now this is balanced. Now what about other atoms or atoms of other elements? So let us take now let us see, we are left with oxygen. Here we have 2 oxygen, and at this side we have 2 here and 2 oxygen atom here. So overall 4 oxygen atoms at this side, right? So in order to balance this, what we are going to do is we are going to write, we will take that molecule where the number is less. So this side has less number of oxygen, so we will increase its number and make it equivalent to the number of oxygen atom towards product by writing 2 over here. So to make it 4. So as soon as we have written 2 in front, as coefficient of oxygen gas, it makes 4 oxygen atom. Here also we have 4 oxygen atom, 2 from carbon dioxide and 2 from water molecule. Now this is balanced. So after doing all this thing, what we are going to do is we are going to just write it down neatly. So CH4 plus 2O2 gives CO2 plus 2H2O. Now using, this is balanced chemical equation. Now using this logic, you try balancing. So this is for you, some questions. Balancing question, balance K2CrO4 this is potassium chromate with barium nitrate, BaNO3 twice. When it reacts, when potassium chromate reacts with barium nitrate, it forms barium chromate, BaCrO4, and potassium nitrate. So KNO3. Okay. So now try to balance this using the same logic that we used in the previous two examples. So I will show you how to balance this chemical equation. You try first, and I will show you in the next class how to balance this. Or I can even show you here also. What you can do is you first pause this video and try to balance it, and then see the solution. So what we have got over here is we can, by hit and trial method, we can find that this compound has maximum number of atoms. So one barium, two nitrogen, and six oxygen, right? So this again, this two in subscript belongs to both. All these um, elements which are present inside this bracket. So 6, 2, 8, and 1, 9. So overall 9 atoms. Others have less than 9. So and hence this compound has maximum number of atoms. Now we are going to balance atoms of this compound first. Barium. So we have one atom of barium. Look for barium atom towards product. We have one atom of barium. So barium is balanced. What about nitrogen atom? Two atoms of nitrogen. Towards product side, we have one atom of nitrogen. So this is not balanced. And in order how to balance, how can we balance it? By, so first let me put those boxes. Now, in order to balance this nitrogen, what we need to do is we need to add a number in front of this, and what that number should be 2, right? This 2 makes 2 nitrogen. Here also we have 2 nitrogen. Now the next atom is 6 oxygen in barium nitrate. And how many atoms we have got over here? 4, and see, 3 oxygen atoms in KNO3, and there are 2 molecules of KNO3. So overall, how many oxygen atoms? 3 times 2, which is 6. 6 here, oh, sorry, 6 plus 4, 10 this side, and this side we have, so here we have 6, and also we have 4 oxygen this side. So there are 10 oxygen atoms this side. So it is already balanced oxygen. 6 plus 4 in reactant side, and 6 plus 4 this side. So overall 10 oxygen atom and 10 oxygen atom, both sides, it is balanced. So all the atoms of this compound is now balanced. Now let us see other atoms. We have potassium here, 2 potassium. This side also 2 potassium, it is balanced. Chromium, 1 chromium this side, 1 chromium only this side. This is also balanced. Oxygen is already balanced. Nitrogen and barium is balanced. So now it is balanced. And this reaction, what we did is just by writing 2 over here, the whole equation got balanced. So at the end, we will finally write the balanced chemical equation. So K2CrO4 plus BaNO3 twice, it gives BaCrO4 barium chromate CrO4 plus 2 molecules of KNO, potassium nitrate. So this is balanced chemical equation. So we are done with this topic of balancing chemical equation. If you want, you can try other chemical equations also. There are several examples given in your textbook, and there are several questions also in your exercise, even in your textbook. So you can try those, and if you feel any problem, then let me know through comments. In the next class, we will see different types of chemical reaction.